Thank you, everyone, for joining us. My name is Shayan Biswas. I'm a principal product manager with Amazon Aurora and RDS. And today I'm going to show you how you can scale your applications with RDS Proxy. We have about 30 minutes and a lot of ground to cover, so we are going to get started quickly. I'll start off by describing some of the motivations that went into building RDS Proxy. Then I'll showcase three key benefits of RDS Proxy and show you how you can scale your applications better with Proxy, make them more available, more resilient, and also make them more secure. Next, I'm going to run a demo where I will show you these benefits in action. And since its launch, RDS Proxy launched at reInvent in preview last year and became generally available middle of this year. Since its launch, thousands of users have used RDS Proxy. So there are things that we have learned by working with our customers. So I'm going to discuss with you some of the best practices and how you can optimize your use of RDS Proxy. Finally, I'm going to conclude with an announcement. There's something new that's coming in RDS Proxy. I'll talk about that and we'll conclude there. So firstly, what do applications running in the cloud require? What do they demand? One is scalability. So whether you are building and running a modern serverless application or you have a traditional application running on Ruby on Rails, PHP, what have you, in either cases, you are able to typically scale your application tier very quickly. For example, if I take Lambdas, Lambda functions can scale to 100,000 invocations, no problem. And if those Lambda functions open 100,000 database connections, that's where there could be challenges. And as you can see, it's not very effective to do that. If you open those many connections, your precious database compute and memory resources are used for just managing and handling these connections instead of processing your queries, which is wasteful. It's not best for your price performance either. The other thing that applications desire and want to have is better availability and ability to tolerate transient failures. In the cloud, there could be failures happening all the time. Specifically in RDS and Aurora, we detect if there's a problem with your database and we automatically fail over. And applications want the ability to be able to sustain through these failovers without any interruptions and without having to maintain any failure handling logic in their application. So that's something that we have heard customers ask for. Finally, everyone desires more controls, better security controls, so that they can maintain better access to their database and in their applications don't share any credentials. So with these motivations, what we saw prior to RDS Proxy's launch, customers had a few choices. First was they could over-provision their database instance and use that to service a lot of connections. Now that's obviously, as I said, is very ineffective because now you're using a database's CPU and memory just to handle a ton of connections. In addition to that, you also have to maintain complex failure handling logic in your application. To be able to still manage whenever there are failovers, you would want to reconnect, retry, and make sure your application is not just falling over because there was a database failover. The alternative is a database proxy. A database proxy is something that sits between your application and your database and allows you to pool connections and sustain connections, preserve connections when there are failovers and things like that. But if you are self-managing a proxy, you have to deploy it, you have to patch it, you have to manage it, and it becomes yet another component in your application architecture that you have to deal with in terms of doing the heavy lifting of managing and running that proxy. And that's not something that differentiates the end outcome of better business applications. In addition to that, a proxy is the entry point to the database, which means that it has the potential to become a single point of failure. So from that perspective, if you're running a proxy yourself, you have to ensure that it has adequate capacity, that is able to scale with your application and manage all the connections from your application, and that it's highly available. It is distributed, and if there's either a node failure or an AZ becomes unavailable, you're still able to sustain through that. And all that is a lot of complex, undifferentiated work. So with this, context, we heard from a lot of customers they wanted a fully managed database proxy service, and that's why we announced RDS Proxy. We built this service. It's highly available, which means it's distributed across multiple availability zones. Even if there's an AZ which becomes unavailable, we run out of the remaining availability zones to continue operating and maintain connectivity with your database. Of course, the benefit of it being fully managed is you don't have to deal with patches, upgrades, and things like that. It's also fully compatible, biocompatible with MySQL and Postgres, which means that if you have an application which is built for MySQL or Postgres databases, all you simply have to do is change the endpoint that you're connecting to. That's all. We support three key features on RDS Proxy. First is connection pooling with multiplexing, and I'll describe this a bit more in detail in coming slides. In effect, what we do is within transactions, whenever there are gaps, we take these database connections from the proxy to the database, and reuse them to service multiple application connections from the application to the proxy. And this gives us a funneling effect, wherein you can support a large number of application connections with a smaller set of database connections. The second key feature here is that RDS Proxy supports faster and seamless failovers. As I was saying, Aurora and RDS multi-AZ configurations, in those configurations, we detect if there's an issue with your primary instance and we fail over. When the failover happens, because RDS Proxy is sitting in between your application and your database, it is able to preserve the connections as the failover is happening and resume those connections and transactions once a new instance becomes available. And it does so by going around the DNS. So you don't have to deal with any DNS caching or downstream TTL delays. Or your own application connection pools, having connections to an old primary instance. And so because it's able to, avoid all those delays, it is able to provide up to 66% faster failovers. When it comes to security, RDS Proxy integrates closely with Secrets Manager. And so you don't store any credentials in the proxy itself. Secrets Manager is, again, a managed service where you can store your usernames and passwords, things like that, secrets. And it also gives you the ability to enforce IAM authentication. IAM authentication is supported in MySQL and Postgres databases on both RDS and Aurora. With RDS Proxy, what you can do is you can say that all my clients must use IAM authentication. And that way you can ensure that no one is storing credentials, username, or passwords, database passwords in their application configuration files or within the application itself. So just a quick schematic of how RDS Proxy gets situated. And so on the left-hand side on the screen, as you're seeing, example applications, you have Ruby on Rails, PHP, or you're running containers or Lambda-based serverless applications. Any of these applications will connect to the proxy. The proxy sits between, as I said, your application and database. And then it provides you connection pooling, seamless failover, and better security controls, because now you can enforce IAM authentication and store credentials in Secrets Manager. It connects to Amazon RDS MySQL and Postgres databases, also Amazon Aurora MySQL and Postgres databases. So those are the choices available to you. Let's dive a little bit deeper in terms of how RDS Proxy helps you scale better. So what we see here is a very simple representation. You see three connections coming from your applications connecting to the proxy, and the proxy is only using one connection. Of course, it's very simplistic. But the idea here is that what we see oftentimes with applications is that when they open a connection, they are not always continuously executing transactions on them. So you may do a select, you get the result set back, do some operations on it, and then go back and execute an update or an insert, something like that. During these operations, between these operations, whenever there are gaps between transactions, what RDS Proxy can smartly do is detect this gap and use the database connection to service another application connection. And that way, it increases the scalability of your application and induces better efficiency in the database. Helps you use your database resources better because now a smaller set of database connections are being shared across multiple application connections, and it's able to service all those application connections. Versus if all those applications were to connect directly with the database, first, it will lose resources in managing all those connections. Second, there's a possibility that it runs out of connections. And then there's a brownout, and then you experience downtime in your application, which is, of course, not the way you would want things to operate. So depending on the size of your database and your workload, you could support up to hundreds of thousands of connections using RDS Proxy because of the multiplexing effect that we get. So that's about scalability on RDS Proxy. Again, I'll show some of this in the demo and how this works out in practice. Next is availability and how RDS Proxy improves availability for your application. Again, extending on that schematic, what I'm showing you here as two database instances. Think of the purple one as the primary and the other one as the standby. And first thing that RDS Proxy does is that any connection that is not actively executing a transaction, when a failover happens, it would preserve those connections. Second, it will also continue to accept any new connections that come in. And third, it will also allow you to queue up any transactions you send through when a failover is happening. Now, taking example of Amazon Aurora, where the failovers are fast, they happen in about 10 seconds. But if you're connecting to the Aurora cluster endpoint, which is the DNS endpoint, the overall failover time that we observe is about 30 seconds. And that's because approximately 20 seconds of that goes in just DNS propagation delays. On top of that, if you have downstream TTLs or if you have application-side connection pools with long-living connections, your failover experience or the time becomes even longer. Versus with RDS Proxy, because it connects directly to the database instances, it is fully aware of your Aurora cluster topology, it is able to detect a failover immediately once Aurora initiates it. And as soon as a new instance comes up, it will be able to connect to it and pass on any pending transactions that it queued up. And as a net effect of this, what you get is up to 66% faster failovers and seamless failovers because your application connections are now not being disrupted. You are not seeing any interruption from the failover. You only see an increase in latency as the failover happens. So any transactions you execute, they will have to wait in the queue and then they get executed. Again, I'll touch upon this aspect of the proxy as well in the demo as we move along. So here's a chart which shows us we did about 100 iterations of a test wherein we used a client to connect directly to the database and then through the proxy. The orange line shows that direct connection and the failover time as a result of that. So how long did it take for the client to be able to reconnect after a failover and execute a transaction? And what we see in the orange line is that the failover times are anywhere between 10 seconds to 50 seconds. And that's coming from by the way, the numbers here are in milliseconds. That's why I converted them. But when we look at the blue line, we see that the failover times are almost always less than 10 seconds and typically around 3 seconds. So that's what we are observing on this graph. And this is using the MariaDB Aurora driver, which is already optimized to reduce the failover time. It does optimizations to be able to reconnect. So it is able to, RDS Proxy is able to, in fact, provide you faster failovers even compared to this optimized MariaDB Aurora driver. Looking at the security aspects, first thing I want to talk about is how you authenticate and authorize RDS Proxy. So of course, you can continue to connect with RDS Proxy the usual way you establish connections with your MySQL or Postgres databases, which is with the username and password. That's always there. In addition to that, what you can do is you can store your secrets in Secrets Manager and then make an API call to retrieve the secret. So you get the username and password. That way, you're not storing the credentials in your application. That's the benefit. And then use that to connect. Another added layer of control that you achieve with RDS proxies, you can say that, hey, you know what, I don't want to pass in usernames and passwords. What I'm going to do is I'm going to use my IAM execution role. So you can use the IAM execution role associated with your Lambda function or with your EC2 instance and use that to authenticate with the RDS proxy. RDS proxy, of course, sitting in between provides you connection pooling, seamless failovers, and improved security. On the other end of it, once you are authenticated with RDS proxy, it will then, when you configure RDS proxy, when you create it, you give it secrets. These secrets are usernames and passwords it is supposed to be using to connect to the database. So when you are authenticated with RDS proxy, it will then go back to Secrets Manager, fetch those credentials, and connect to your database of choice. So just quickly highlighting where you can enforce this on the console. As you can see here, there's an option to make IAM authentication required. Just a quick flow of how it looks in the code. You request an authentication token. Instead of your password, you get a token. Once you get this token, you use this token instead of the password to connect to RDS proxy. And beyond that, the process, as I described, RDS proxy will retrieve secrets from Secrets Manager and connect to the database. Quick code snippet. This is in Python, but it should be replicable in any other language if you so desire. The highlighted line shows how you generate a token based on our SDK and get that token. Once you have that token, again, you will notice here is that in the password, we are passing the token, not the password, right? So you no longer in your code have access to the password anywhere. You're not storing it in some configuration file. You're not hard coding it in the code, or you're not even retrieving it in the application. There's just no access to the password. The last aspect which I want to talk about is how you can configure security groups in RDS proxy. So when you look at RDS proxy, there will be 3 security groups you'll be primarily concerned with. First one is the security group for the application, and that will control how you talk to the application. Second one is for the proxy. Here, what you would want to make sure is that you allow inbound access from the application to the proxy. And finally, on the database, you would want to make sure that the proxy has inbound access to the database. You could also open up the database security group to allow your application to talk directly to the database if that's something that you want to do. So with that, I'm going to jump into our demo. And to save us time, what I've done is I've already created a proxy. And this proxy let's give it a go. And this proxy, it's very easy to set up. It takes a few moments to create, but I want to save the few minutes it will take to set up. There's the endpoint for the proxy. We'll come back to that. The database has already been created. Let's look at the security groups just to tie back to the previous topic I was discussing. So as I said, there are 3 security groups. And let's first start with the client security group and look at the inbound roles. So this is an EC2 instance security group. I'm going to be SSHing into it, and that's why I've allowed SSH from my IP address. Then this is the security group for the proxy, and here you would notice that we have allowed inbound access from the client security group. So we are allowing the application to connect to the proxy. Excuse me. And the last piece is the database. And there you would notice that I have added 2 inbound rules. One is to allow the proxy to be able to talk to the database. The other one allows the application or the client to be able to talk to the database. Excuse me. So let's go back to our console and look at the database. So this Aurora database, you would observe that there are two instances. Both are R5 large instances, DB5 larges, and they support about 1,000 connections by default. What I'm going to do is I'm going to use this cluster endpoint and connect to the database and run a query to look at the number of max connections that are configured and the current connections that are there. Excuse me. So there it is. We see that there's timestamp, max connections of 1,000, and current connections 8. There's not much going on in the database. Nothing is actually connected to it. So those 8 sessions are essentially for our monitoring services that RDS Proxy and RDS generally use to connect. Moving on to CloudWatch, this is a CloudWatch graph where we are representing 2 metrics. First one is database connections in orange. And the second one in blue is the connections to the proxy. The connections to the proxy are shown on the left-hand side and the connections from the database on the right-hand side. There's a simple Lambda function, which I'm running a loop in, which is connecting to the database, executing a simple query as you see. And I'm going to use this Lambda function as a client. And to simulate additional load, what I'm using here is Artillery. Artillery is an open source tool, and we are going to use Artillery. I have a script written, there you go. Artillery is starting up, which is going to start firing up tons of Lambda functions. And these Lambda functions, as you observed, each one is doing 10 connections. So what we see here is the Artillery has already started, and it has fired off 66 Lambda functions, each one of them creating 10 connections. So at this point, 660 connections are going through, and it will continue to increase the load as we go on. So let's look at and observe the CloudWatch dashboard. These are 1-minute metrics. So we see the first data point come in for the blue line. And then the orange line also, we are seeing it is progressing. Now we have more connections. So there's 10,000 connections on the proxy and just 900 connections or close to 900 connections on the database. And that's because I've configured the proxy to have only 90% of the connections, so 90% of 1,000. Now this is the peak. We have reached 15,000 connections, or 15 times as much that the database could have supported on its own. So that shows the immense power of RDS Proxy and how much you can scale your application. And it's executing all those queries in the background as this is happening with just the 900 connections. Next, I'm going to move on to the next phase of the demo where I'll show how seamless and faster failovers work. So we have 2 instances. One is a reader, one is a writer. And I'm going to use the cluster endpoint again. And let's go back to our MySQL prompt. And what I'm going to do here is run the exact same query that I showed you previously in a loop. And we'll continuously run this. Let's use this connection string. And as you see, every second, 4 times this query is being executed. You see the timestamp, number of max connections or current connections. So let's initiate a failover. Yes, confirm that. And that should start rolling. The failover will happen in a few moments. What you will see is these current connections, which are coming from the proxy. Of course, it's still running the Artillery workload. And when the failover happens, these connections would drop and you'll see an interruption. There it goes. As you're seeing errors on the client that it's not able to connect to the server, that's expected. And all the connections are also gone. So I'm going to stop the loop. And we see that from 9:29:59 to 30:06, so about 7 seconds, there was a disruption. This is already very fast. And it happens, the failover happens so fast because of Aurora storage architecture and parallelization. So it's coming from there. Next, what we are going to do is we'll do the same exact thing, but with the proxy. So I just copied the proxy endpoint, and let's run the same script with the proxy endpoint. And what we expect to see here is minimal disruption. We will not see any errors. And the failover would be even faster than the 7 seconds we saw. So let's switch back to instance 1, which was the initial primary instance or writer instance. I've initiated the failover. And so we'll go back to our console, and we see here that it's still sustaining the connections. The failover has not kicked in. The marker we want to look for here is the number of current connections. So let's wait for a few moments. It's going to kick in, and what we'll see is there. So let's stop running the loop. I'm going to stop it. What we see is that there's just no interruption. There are no errors because the proxy continues to take connections even when the database is not available. And within 2 seconds, 32 to 34, within 2 seconds, it was able to reconnect to the database. And the only marker we see here is that the number of connections to the database dropped. Because, of course, the database process restarted, and so all the connections that were established from the proxy to the database are gone. But the proxy sustained the connections. So that concludes our demo. It showed us that we are able to scale instantaneously with RDS Proxy, and also able to provide you seamless and faster failovers. So some of the best practices that we learned from customers, as I said previously, applications don't continuously use connections, right? So there's one application, there's a transaction goes through, it's done with it, then the next application, instance asks for a connection, and so on and so forth. So RDS Proxy is doing this transaction level load balancing and sharing that improves scalability. It also helps minimize resource overhead on your database instance because now your CPU and memory can do what they are supposed to do in a database instance, so that is to process queries. There are some situations where this multiplexing may not work, and that is when you change the session state. If your application is using session state, and if we end up reusing your database connection, then we will be leaking this session state, and we want to do that. And there's a safeguard in the proxy for that. That's called pinning. So for the lifetime of the application connection, it will be pinned to the database connections, but then it's not been multiplexed. So what are the situations when pinning can happen? When you're setting variables, locking functions, prepared statements, things like that. Or if you have large queries, very large queries, 16 kilobytes in size, then you will also get pinned. We don't pin on changes to character sets, time zones, collations, auto commits, and SQL mode changes. These are tracked by the proxy. So if you're setting these things, the proxy will remember that, and when it is reusing a database connection, it will make sure that it is associating it with the right configuration. Stored procedures, if you're changing anything, those things we cannot, of course, look inside the stored procedures. You would want to be careful what you're doing there. And if you're changing session state, maybe you want to execute those queries outside the proxy. Finally, even when there's pinning, you are still able to reuse your database connection. So once the application connection goes away, we reuse the database connection for other application connections. Another thing to note is when failovers happen, pinned connections are dropped. Those connections cannot be seamlessly transitioned to a new instance. As you can imagine, we can't share the session state or replay the session state. So just quick 2 tips on how you can avoid pinning. One is if you don't care about variables being shared between sessions, you can exclude variable sets. And the other piece is initialization query, wherein you can set a set of variables or session settings, things like that. You can execute a query for that matter. That proxy with each new database connection, when it pulls from the pool, it will execute this query on that. And that way you have consistent session state without resulting in pinning. Bunch of metrics that are available, 24 metrics that you can use to monitor your proxy usage. What I would like to point you to is the pinning, session pinning CloudWatch metric, which you can watch and make sure that if there's too much pinning happening, then you would want to make sure that there's the other alternatives that you're using for it. The other piece is when you have lots of database connections and currently borrowed connections. So if you have borrowed connections and database connections, they are almost the same all the time, which means that you're running out of capacity in terms of connections. And then you would want to watch borrow latency, which will tell you that if there are too many client connections or application connections waiting for connections to become available. And at that point, you would want to scale your database potentially. So that's another marker you would want to look for. So what's next? In terms of new features, I'm excited to bring to you this announcement that Aurora read replicas will soon be supported on RDS Proxy. RDS Proxy is fully aware of your Aurora cluster, but today it routes the traffic only to the primary instance. With this new launch, once we make it available, it's also going to be able to provide all the same benefits: connection pooling, faster seamless failovers, better security for read replicas in your Aurora clusters as well. It's going to function very much the same way. So you will have two endpoints: one, the primary endpoint for the write workload, and then the read-only endpoint for the read replicas. And then we are going to, of course, also support it for both Aurora MySQL and Postgres. So this is coming soon on RDS Proxy. Here are a few resources that you can refer to learn more about RDS Proxy and how you can use it to scale your applications better, make them more available, more resilient, and more secure. Finally, some sessions that are coming up, related sessions. There are 4 of them. I would highly encourage you to also watch these sessions and hope you find them useful. And with that, we have come to the end of our session. Thank you. Please do fill out the session survey. That's the way we improve our sessions on an ongoing basis, and appreciate you joining us today.